All right, guys. So this is the third case in section three, progressive bars, right? So in the second case, we learned to use the waiter package, right? And we used the waitress function, and that created this progressive bar, right? Now, what if we don't know exactly how long the operation is, right? Then we just want to show the spinner um, to let the user know that it is working. Something's going on, right? Just wait. Um, so for that, we're going to use waiter function instead of waitress function, right? So we have the code on the left, and let's compare this uh, with the waitress function that we had for the progressive bar, right? So UI side, UI side, it's the same thing, I think. So on the UI side, all you need is use. Oh, so instead of waitress, it should be use waiter, right? Yeah. So on the UI side, you need use waiter function instead of use waitress function, right? So waitress function is for progressive bars, and waiter function is for spinners, right? And if you look at the server side, um, so let's uh, yeah, if you look at the server side, event reactive. So hold off until this event, which is the action button go. And then you have a waiter function instead of waitress function and access new, right? So new here is to call this progressive bar or spinners. And then the interesting thing is waiter and show. I think that is to start the spinners. And we have the same on.exit function to make the progress bar to disappear, in this case, spinners, right? But instead of waitress functions close, waiter function uses hide, right? So show and hide. And the, another major difference is, I'm sorry, the for loop um, is not there. So instead of for loop, we have sys sleep. Now, um, we do have system sleep function in the for loop here, but instead of providing half a second for the system sleep function, we have this random selection function of sample. So, we provide two values here, 5 and 1. What that means is select one random number from 1 through 5. That's what it means. So basically, what this means here, this function represents or indicates that this uh, the calculation is random, right? So we don't know how long it'll take. It it will take maximum of 5 steps or 1 step at minimum, right? And then it generates a random number from the uniform distribution, right? So right, let's do this. So we're gonna save this as number 3 and save. And let's just delete this, the first case, and let's comment it out. I want to keep it here to be able to compare the code. And also here, instead of, so let's comment this out as well. Instead of waitress, use waitress function, which is for progressive bar. For spinners, oh, not yeah, this is a code, not a label. Um, waiter, use waiter. So this is for spinners, okay? And so instead of waitress, right? We're gonna use waiter. So we're gonna, and also we want to save that in an object. Let's call it waiter, and waiter package and waiter function, and then new, right? And then let's use this object waiter. Again, this waiter is not the same as this waiter, right? That waiter is a package. This waiter here is an object, right? And this will be show, right? And then we want to make the spinner disappear when it's done. So exit on exit and waiter and then high, right? Um, and then we want to add the randomness, right? So we have the system sleep, but we don't want to provide a fixed value, right? Because whole point about this app is to show the use of spinner, right? When we don't know how long an operation takes, right? So here we use sample and 5 and 1. So what that means is, I have this is sample 5 and 1. Um, so it randomly selects. So if you look at the documentation here, right, sample, and then first two argument x and size. Those are the two mandatory arguments. So x here is either a vector of one or more elements from which to choose randomly, right? Or a positive integer, which is our case here. So the author provided positive value, right, which is 5. So if you look at the detail here, if x has a length 1 and is numeric and greater than 1, right? Then what that means is 1 colon x. So in our case, 1 colon 5, and that is 1 through 5, right? So what this means is second value 1, that is a value that we provide for argument n, right? So randomly select one value from 1 through 5. So that's basically what's happening here. So every time you run this code, it randomly selects one value from that vector 1 through 5. Okay, so that is what is happening with this system sleep sample of 5 and 1, right? So every time you run, um, you don't know how long an operation will take. It could be 1, it could be 3, it could be 5, right? So and then after that, does the work. Randomly select a value from a uniform distribution, one value. Okay, so that is what we're doing here, right? Run app, right? Go. So spinner. Right. So that was a little long. Um, Hold on. Do we need numeric input here? Because that's not necessary. How many steps? Um, yeah, I don't think that is necessary. Right. So we can take that out. Right. So numeric input, not necessary. Right. So we go, spin, go. Yeah. So this time it was a little bit longer than the previous ones. So it's um, the length of the operation, right? It's randomly selected from 1 through 5. That's what's going on here. Wow, this one was way longer, right? All right. Um, oh, uh, so that is the general case of a spinner. But then, what if we want um, spinners for specific outputs? Okay. So if that is what we want, so let's look at the code here. So here, in the waiter new function, we provide input ID. Okay, we provide input ID, and then there is no longer on exit uh, function provided here. Okay, and it is doing what? So instead of printing a value, a random value, it's making a plot. Um, okay, so let's try this. All right, so let's go to RStudio. Why don't we? So let's close this. Um, let's save this section 3.3 as part A. So rename part A, part A. And let's create another file for part B. And let's make this spinner for specific output. And so let's delete this. And again, let's comment this out, right? Shift Control C for comment. Um, and again, I want to keep it here to be able to compare the code, right? Um, so for now, just to be consistent, instead of making a plot, I'm going to keep the output as results, just printing a random value. I just want to focus on creating spinners for the specific output. All right. So again, in the previous case, we created this spinner object and saved it later, and um, we use that in the following code, right, to show and to hide and so on. But when we make spinners for a specific output, um, we're not doing that. Um, that is because the show function is here. It appears that we don't need on exit function, and that is the reason why we're not saving it. Okay, all right. I'm not entirely sure why in this case we do not need on exit function, but let's see. Okay, so waiter package, and then waiter function, and then new, right? And then in the new function, we're going to provide ID, and which is results. Again, I'm not going to, first I'm going to keep the same results just to focus on comparing the code between these two cases, right? And then show, show spinners, right? Um, oops, what just happened? All right. Okay. And the other thing is system sleep, instead of providing random number, right? We provided random number because that was the case where we didn't know how long an operation would take, right? But this time, we know how long an operation will take because we have a specific output here. Um, all right. So system sleep and 3 seconds. And we want to keep the same thing, same output, random selection from the uniform distribution. Okay. And let's see what happens here. All right, so let's hit go. Right. Where's the spinner? Oh, there. There's a spinner going. Yeah. Okay. So it will be more obvious when you have more complex app and it does multiple tasks. And so the spinner is specific to one task among the multiple tasks that the app does. This it'll be easier to see the spinner is for that specific task, right? Uh, right. So go. Yeah. Yeah. It doesn't seem like on exit function is needed because spinner ends or disappears. Yeah. When we have the output. Okay. But I mean, I think we could use the same code here, which is to save this. I'm gonna just try waiter and then alt dash and remove that just to be consistent with the previous code. And then the next line, waiter show, and then the next line on dot exit waiter hide once the task is done, right? Would this make any difference? Oh, did I misspell it? Waiter, right? So go. All right. So it doesn't like it. Error event reactive value function. Oh, another misspelling. Uh, where did I put it? Hold on. Run that. Okay, so that was the previous error. Go. I'm not seeing the spinner. Oh, there we go. Yeah, it does the same thing. Yeah, so um, whether we have this on exit function or not, it doesn't make a difference. I wonder in the previous case as well, we could have used this, you know, we could have used just the code that we we got here. So in one line, we add show, right? And go without on dot exit function. I wonder whether that will be simpler code in the previous code case. All right. So that is it for progressive bars. And I'll see you in the next video for section 4 of this chapter. Take care.